The title of this lesson is Every Half is Not the Same. But it's not just every half that's not the same. When you take something and you divide it into parts, all of the parts have to be the same size, but if I take a half of one thing, it may be a different size half than if I took the half of something else. If I took half of an apple pie, it may be much smaller than half of a pizza. So let's look at this and see. We know that, excuse me, our top number is the numerator and the bottom number is the denominator. Reminder, the denominator tells how many pieces the whole is broken into. So in this fraction, my denominator tells me that the whole is broken into 2 pieces. Or it may tell me how many pieces it takes to make a whole. Okay, here's an example. I have a circle lying down the middle, I have 2 equal parts. These 2 parts make the whole. It's my denominator and my fraction. So if I have 2 parts, my denominator is going to be 2. If I'm talking about the fraction 1/2, I'm talking about one of those. So my fraction would be 1/2. But the denominator does not tell me how big the piece is. Just tells me how many it takes to make the whole. So let's look at these 2 examples. Obviously, these are 2 different size squares. And if I take half of this one, so I'm talking about 1, it takes 2 to make the whole. And I could come over here and talk about half of this one. I'm talking about 1. Takes 2 to make the whole. But look at the 2 halves. Half of this is much smaller than a half of this. So the denominator tells how many it takes to make the whole, but it doesn't tell me how big that half is. Of course, the other half has to be the same size. So, just how many it takes to make the whole. No matter what the denominator is, remember, it takes that many to make the whole. So if I look at these 2 circles, I can see I've divided these into fourths, because it takes 4 equal sized pieces to make the whole circle. Here it takes 4 equal sized pieces to make the whole circle. What if I wanted to talk about 1/4 of that circle? I could write the fraction 1/4. I'm talking about 1. It takes 4 to make the whole. My fraction's 1/4. And what if I came over to this little circle and I shaded in 1/4, 1/4. Again, I'm talking about one of them, but my denominator's 4 again. But you can see here the fourths are much smaller than these fourths. So you have to know how big the whole is to know how big the fourth is. So just because the denominator is a 4, those fourths might be different sizes. One may be much bigger and one may be much smaller. Sometimes the denominator may be made up of pieces put together. You need those pieces put together to equal the whole. Now this can get a little confusing, so watch for the examples. My fraction is 1/3, and I have all of these x's. Well, I'm going to be talking about one of them, but I have to get these x's divided into 3 equal parts. So what should I do first? I need to count to see how many x's I have. 1, 2, 3, 4 across. 1, 2, 3 down. 4 times 3 is 12. So I have 12 x's. And now I've got to get those 12 x's into 3 equal groups. How can I do that? Well, what's 12 divided by 3? I've got to get it in 3 equal groups. So how many will I have in each group? 4. So if I circle this, there's one group, there's one group, and there's one group. Are my groups equal size? Yes, there's 4 X's, 1, 2, 3, 4, in each group, and there are 3 groups. So if I'm going to talk about 1/3 of this group of X's, I'm going to be talking about all of these. So how many is in 1/3 of 12? 4. I'm talking about 4 of those X's. Look at this one. Again, I'm going to ask you to find 1/3 of a group. These could be stamps, coins, baseball cards, anything. But you have this many, and I want 1/3 of them. You have to give me 1/3. First thing you have to do, count, see how many you have. 1, 2, 3 across. 1, 2, 3 down. 3 times 3 is 9. So I have 9 of those. And I got to get it into 3 equal parts. So remember, I have to have 3 parts to make the whole. So I got to get it into 3 equal parts. Well, 9 divided by 3 is 3. So I have to get these into 3 equal parts. And there are 3 in each part. 1, 2, 3. 1, 2, 3. 1, 2, 3. So if I want to talk about 1/3 of 9, I'm going to be talking about this many. Well, how much is 1/3 of 9? 3. So over here, 1/3 was 4, but over here, 1/3 is 3. I have to know my total that I'm working with. Here's another example. This time I'm talking about sixths. How many sixths? I want to talk about 1 of the sixths. So first I have to make sure I have 6 over here. 1, 2, 3, 4, 5, and 6. And I want to know about 1 of them. Well, that's easy enough. I'm going to shade in 1 of the 6. But I get down here and I have a baseball card collection. And I'm going to sell 1/6 of my cards to make some money for a trip that I want to go on. Maybe I want to go to a baseball game. So I need to count first, how many baseball cards do I have? 1, 2, 3, 4 times 1, 2, 3. 4 times 3 is 12. So I have 12, we're going to say I have 12 cards. And I'm going to sell 1/6 of them to go to the baseball game. So I've got 12 cards. I need to get into 6 equal groups. Well, how do I put 12 into 6 equal groups? If I had 6 people sitting there and I have 12 baseball cards and I give everybody a card, when I finish, how many will everybody have? Everybody will have 2. So to put 12 cards into 6 equal groups, I'm going to have 2 in a group. There's 2. There's 2. 2, 2, 2, and 2. So what is 1/6 of 12? How many's in 1/6? 2. So 1/6 of 12 is 2. I would have to sell 2 of my baseball cards in order to be able to go to the baseball game tonight.